Okay, so with Java 21, something huge happened in the world of concurrency. It's a feature called virtual threads. And listen, this isn't just some small tweak, it's a total game changer for how we can write high-performance apps. So let's dive in and break down what makes them so incredibly revolutionary.
Let me just start by asking you this. What if you could handle a million things happening at the same time? A million user requests, a million database queries, whatever, all without your server even breaking a sweat. I know it sounds kind of like science fiction, but this is the exact problem that virtual threads were built to solve.
Now, to really get why this is such a revolution, we got to take a quick look at how things used to be. For decades, Java has relied on something called platform threads, and, well, they come with a pretty serious bottleneck.
In the old model, it was simple. One task, one thread. So, a user makes a request, you spin up a platform thread to handle it. The problem is, that platform thread is basically just a wrapper around a super heavy, super expensive operating system thread. It's kind of like hiring a full-time employee with full benefits just to do a 5-minute task. I mean, it gets the job done, but it is wildly inefficient.
And just how inefficient are we talking about? Well, every single platform thread you create sets aside a big chunk of memory for its stack, often a megabyte or even more, the second it's born. And that's a fixed cost. It doesn't matter if the thread is doing heavy math or just sitting there waiting for a network response. So if you want to create a few thousand threads, you're going to need gigabytes of memory just for their stacks alone. It's crazy.
At the end of the day, this one thread per task model just doesn't scale for modern applications. Platform threads are a scarce, expensive resource. Trying to build a massive, high-throughput service with them is like trying to build a skyscraper with a handful of really expensive, custom-made bricks. You're going to hit a hard limit, and you're going to hit it fast.
And this, right here, is where Java 21 completely flips the script. This is the new way of doing things, thanks to the virtual revolution. So here's the fundamental shift. Platform threads? They're heavyweight, they're managed by the operating system, and you just can't have that many of them. Virtual threads. They are incredibly lightweight, managed entirely by the Java virtual machine, and you can create tons of them. We're talking millions. We've literally gone from a world of scarcity to a world of abundance.
So how in the world does the JVM pull off this magic trick? Well, it all comes down to this really clever cycle of mounting and unmounting.
Okay, imagine this. The old platform threads are like a small fleet of very expensive company cars. And the new virtual threads, they're like a massive team of gig workers. So a worker, that's our virtual thread, grabs a car, the carrier thread, to go do a job. But the second that worker has to wait for anything, like a network call to come back, they instantly park the car and give the keys back. This is called unmounting. And now that car is immediately free for the next worker who's ready to go. This makes sure those expensive cars are always being productive, never just sitting idle.
All right, so the unmounting thing is super efficient, but what makes them so cheap to create in the first place? That's the real secret sauce, and it's probably not what you think.
You know, there's a common misconception that a thread is a thread, and they all need the same amount of memory for their call stack. Yeah, that's just not true. In fact, the way their stacks are handled isn't just some minor detail. It's the core innovation that makes this whole thing possible.
Think about the old platform thread stack. It's like a giant pre-poured concrete foundation for a house. It reserves that huge, fixed chunk of memory, that 1 megabyte or more, from the OS right away, whether it needs it or not. It's rigid, and it's wasteful.
But a virtual thread stack? It's a completely different animal. It's just a small object living on the Java heap. It starts out tiny. We're talking a few hundred bytes, and it only grows when it needs to. It's more like a backpack that magically expands only when you put stuff in it. This is the secret to their incredibly small memory footprint.
So there's the big aha moment. The whole lightweight thing comes from completely reimagining the call stack. It's not a big, clunky OS resource anymore. It's a flexible Java object, and that's the change that lets us create millions of them without a care in the world.
Okay, the theory is really compelling, but how do we actually use them in our code? Let's get practical and look at the new rulebook, including some really important things you should do and a few pitfalls you definitely want to avoid.
The great news is, the API for this is just beautiful. It's so simple. You can kick one off with a single line of code. Or if you're managing a bunch of tasks, you can use the new executor service. And check out the name, New Virtual Thread Per Task Executor. It does exactly what it says. It creates a brand new, cheap virtual thread for every single task. This means the old idea of thread pooling is basically obsolete.
But just because they're cheap and easy
doesn't mean we can just throw them at every problem. There's one critical mistake in particular that can completely ruin all the benefits we just talked about.
And that brings us to the most important pitfall, something called pinning. If your virtual thread runs code inside an old-school synchronized block, it gets pinned to its carrier thread. It can't unmount. That means the expensive carrier thread is stuck waiting right along with it, and the whole system grinds to a halt. It totally defeats the purpose. The fix? It's simple. Instead of synchronized, use reentrant lock. It's a pure Java lock that plays nicely with the JVM scheduler and lets that unmounting magic happen.
So let's boil all this down to 4 golden rules. First, do use virtual threads for tasks that do a lot of waiting, I/O-bound stuff. That is their absolute sweet spot. Second, don't use them for heavy CPU-intensive work. Those tasks don't block, so they won't unmount, and you get zero benefit. Stick with platform threads for that. Third, and this is a big mental shift, don't pool them. The whole point is that they're so cheap to create and throw away that pooling is now an anti-pattern. And finally, always remember, virtual threads are about improving throughput, handling more tasks at once. They won't magically reduce latency or make a single task finish any faster.
And for anyone who really wants to dive deep into all the technical specs, these concepts are covered in great detail in official guides, like the OCP Java 21 Developer's Guide.
And all of this leads to the ultimate promise here, the ability to build incredibly high-throughput applications, not with complicated async code, but with the same simple, easy-to-read style that Java developers have known for years.
So that's the story. It really is a paradigm shift. We've gone from a world where we had to carefully manage a few, scarce, and expensive workers to a world where we can orchestrate a nearly infinite number of cheap, disposable tasks.
And that leaves us with a really fascinating question to think about. Now that concurrency is basically free and easy, what new kinds of applications and services are we going to build that were just impossible before? The revolution is here, and honestly, it's going to be really exciting to see what happens next. Thanks for tuning in.